Hi guys. This time I'm going to show you some primitive things related to Unreal Engine 4.26, and let's try to create a new project. So let's click on the game project. Let's click on the next, and for example, we will select the third person project. So this is the way how our game will look like. So we have the character. This character is under our control, and here we have the scene. So we'll have a couple of objects on the scene, so we can interact with them and do a lot of other new stuff. So let's click on next. Let's select the blueprint. So we'll use the visual programming language for this game. We will use the maximal available quality. Nextly, we will disable the ray tracing because we are not going to use it this time. And let's create some new project. So I will use the temp and a lot of tools as the folder of the project, and my project name will be my project, and some of the same amount of those brackets. Let's click on create project. Let's wait a bit. After a couple of seconds the project will be on the screen. So it's almost done. Let's wait another couple of seconds. So what do we have here? So literally we have the scene over here in the central part. On the right side we have a couple of element groups we can add to our scene. For example, we can add some geometry objects by just drag and drop on a scene. So you can take a look how this drag and drop happens, and so on and so on. But anyways, we won't need those objects, so we'll just select them, and by pressing delete key they have been just erased from the scene. On the bottom side we have folders, engine folders with some classes we can use, and the content of our project. By default you will see only content of your project, and the content is being split in a couple of folders. Actually, this split was implemented in the template of this scene. That's why we see the structure. But anyways, when you will make your own project, it will be totally up to you which structure or hierarchy folders to make. How we will work with this scene? So literally, we can move through the scene by mouse buttons and by keys AWSD. How we can move our cursor? So first of all, to make just a look around, we have to move a cursor inside the scene, and we have to press right mouse button. So as you see, cursor disappeared, and by moving the mouse we can take a look on this scene. In the same time, while a right mouse button is being pressed, we can use AWSD buttons just to move our camera that looks on the scene. So as you can see, here's our scene. So what do we have here? We have walls, we have floor, we have couple of objects located on the scene. So we have this cube, we have these objects, as well as we have something rotated over here. Literally it's just an object. We have some text on the scene as well, and our character. Okay, so On the right side, we can take a look that we have the word outliner that contains all elements we have on our map. So, for example, we can hide some of them, we can open them, and as you can see, this showing and hiding them work on the whole hierarchy. So literally, every object is being placed on the scene will be located here, and here we can move them in folders. So we can even create the folder, we can combine them, so in other words, so we can group them, and so on and so on. Here in the world settings, we have the main settings of our world. So for example, the game mode, the default information about the player, and so on and so on. But we won't use these world settings a lot. Mostly we'll work with details. And what can we find out in details? So in details we can find out configuration parameters of selected element on the scene. So we can select elements on the scene by just clicking a left mouse button. Sure, before that we have to place the cursor under this object, for example the cube. So we can select the cube, and we can find out location, rotation, scale, mobility settings, and all others, as static mesh, material which is being applied, and so on and so on. So let's take a look on these parameters. So the first of all, we have location. Well, literally here we have so-called a dragger that allows us to just by clicking the left mouse button move cursor on the left or on the right, and by this we are moving the object itself. And it happens in 3 directions, so X, Y, and Z. Okay, so you can see how it happens. So about location, it's clear. It's a pure location of object. And what is the rotation? Well, rotation is angles, as a set of angles we can apply for the object. So as you can see, I'm changing these angles, and object is being rotated around its central point. Well, about the scale, well, we can change sizes of object, and by the way, we can do this for different in different directions. So in direction X, Y, and Z. And sure, those X, Y, and Z directions are original directions of the object. So without this, apply the rotation angle. So for example, if we will click this this arrow, this yellow arrow, so it means that the parameter is being set up to its initial value or a default. So for example, if we will increase object size by using Z, direction, so literally we increase it ahead. So for example, if we would rotate our object, and we will still change the scaling in Z direction, the object will be still changed in its in the same direction. Okay, so what's the mobility? Mobility is strictly related to the lighting options. So there are a couple of different lightings in Unreal Engine. One is static, which has to be cooked. Well, what does it mean to cook lighting? It means that we literally press building of lighting and building of all shadows and everything that's been related to lighting. So for example, if we removed our object and it has static mobility, so it means that the shadow that falls from this object has to be calculated. So right now the calculation stage is happening, so let's wait for a couple of seconds. Okay, so the lighting is being built, so let's wait several seconds. Okay, great. So right now our object shadow is being created, and it's been just drawn as additional picture placed on the floor. And as you can see, the previous picture disappeared. So the previous picture, that black area, was the shadow which was calculated and placed on the floor as just a picture. Okay, what happens with stationary mobility? With stationary mobility, actually, the direct lighting is being built, and indirect or so-called soft lighting shadows are being assumed as dynamical ones, so we don't have to build them. In our case, if we would take a look in our lighting folder, we have the lighting source, and it's exactly direct lighting. So in our case, even if mobility would be stationary, we will have to build the lighting as well. Let's take a look how it looks like. Okay, it will take once again a couple of seconds, because we have quite small scene. That's why it takes a pretty short time. But for examples, in real project, it could take hours, or even some 5 or 10 hours, and it's fine. It's really fine. Okay, so what happens when we have the movable mobility? So when we have the movable mobility, actually the shadow is being calculated every frame for every frame we have in our game. So sure, it's another, or let's say additional workload on the processor. So that's why it's not really recommended to have a lot of these movable mobility objects that through shadow. Okay, so here we have a so-called static mesh actor, which is our cube. So static mesh actor literally means that that our object has a form, and the form is being saved previously into cube chamfer file. Well, let's take a look on this file. If we would click this icon, we would have this object selected in our object browser. So here we have all elements that exist in the folder we select. Okay, so here we have the cube chamfer. We can even double click it, and we can take a look how it looks like. Okay, so in this case we have another scene in which our cube is being placed. It's just a default scene for overlooking the object mesh. Okay, so that's the way how our object looks like. Sure, we stretch it a bit, but anyways. Well, material just allows us to apply colors. In our case, we have the white or some kind of gray color applied. At this point, we're not going to change it. Okay, let's take a look. What do we have else on the scene? Well, we have icon of our light source, and here we have the intensity of light. So, for example, we can change it. So let's say we'll change it to 4, something. Okay, or we can, let's say, change it to 10, something, or let's go back to 2 plus the 2, something. Okay, so that's the idea of these placed elements on the scene. Okay, so what do we have here? We have player placed on the scene. Player has its own class. Well, about these classes we'll talk a bit later. So if we would take a look on configuration of this character, we would find out that there are a lot of a lot of options with a lot of values which we can use, and we can create them on our own, or we can just use a predefined set of configuration. But what we have to take, but what we have to consider from the very beginning, we have to consider from the very beginning that we have the pawn group of options and we have auto possess player. So what does it mean to possess a player? It means that that we actually connect a player to our scene by the characters. So player can control exactly characters on the scene. And here we have our character. Okay, it's actually a bit complicated thing, but what we have to take a look at, we have to take a look at that we are actually saying that player 0 will control this character once game will be started. Okay, so and as you can see, we can have actually 8 players simultaneously on the scene. That's why we can select one of 8 characters, and by default, by the default, our character will be always the bind to player number 0. And actually, wherever we will see a player with index 0, will mean that it's our character which is playing in this game on our computer. Okay, so how can we run this game? So we can run this in by clicking this play button, or we can open a menu related to this play button, and we can use, for example, play in a new window or play the standalone game. It means the game will be compiled and only then run for testing. So what will happen if we will click the play button? So when you click the play button, we can see that the game is being played in our central part of Unreal Engine. And literally, what can we do? We can move the mouse. So by moving the cursor, we're actually looking around the character. So we're rotating our camera around the character, and by using AWSD keys, we can just move our character. So W for forward direction, S for back direction, A for left, and D for right. And we definitely can combine mouse moves and this button press just to move around objects. Okay. So let's close the game by pressing Escape button, and let's take a look how our game will be launched by using other options. Okay, so mobile preview. Okay, we have to select all elements we opened previously. Okay, and game is being compiled, and it will be opened in so-called mobile preview way. Okay, let's wait for a couple of seconds. Okay, it's still loading, so let's take a look if everything will be great. Well, most often I personally use another type of launching the game in testing mode. But anyway, so let's take a look if this one will be run in the end. Okay, so what can we see? We see that actually we have some controls that will be available for for the player. So literally here we will have to touch this left bottom corner for moving the character. So it will be quite similar to AWSD button set. By just clicking somewhere outside these two controls, we will have the jump option. And here by using this controller on the right side, on the right bottom side, we will be able to rotate the camera. So camera will be rotated in direction in which we will move our entire circle. Okay, so great. And here we have the shader compilation. It means that actually all materials and all small tiles of materials of objects are just being compiled. Okay, anyways, that's the idea of mobile launching the game for testing purposes. Okay, let's click escape, or let's just close this window. And more often, for example, I use the computer version of launching, but in a totally new window. Okay, so right now we see that game has been opened in a new window, and we can literally control our character. Okay, so that's the way we can make it. When we select whatever element, we have these arrows. These arrows basically allows us to move object literally in the same way as we would move these location bars, or we would change the location values. And sure, keep in mind that here each direction has its own color, and depending on how we move the object, it depends even in which direction our object will be moved while we are moving these arrows. For example, we can rotate object somehow, and we can try to move it in all these rotations. In all these directions we have in our 3D space. Okay, so let's maybe place just this object somewhere here. Okay, great. Let's press Ctrl S or save all button. Okay, so everything has been saved. Okay, so let's take a look. What is the structure of our character? So let's just click here on the characters class just one time, and the character editor is being launched. Okay, so what do we have here? Here we have components our character is structured from, and in the viewport we can see our character. Okay, so literally our character has the capsule component. So capsule component is just needed to find out if our character touches some areas or touches some floor, and so on and so on. And by finding out these touches with other objects, we can make a reaction. We can program the reaction. Okay, we have arrow component. It's just for finding out in which direction our character is looking. We have the mesh, and mesh in this case is the skeletal mesh that actually means the form of our character. And we have camera boom, so literally we have the camera itself, and we have so-called a camera boom, but in reality it's so-called a spring arm component, just renamed afterwards. So spring arm allows us to make camera rotation on the same distance all the time, and here we can specify this distance. So for example, it will be 12. Pretty regularly here it's been mentioned it's been mentioned in meters. So let's place another value. So for example 20. Wait a bit. Sorry. We have the target arm length. So literally we can specify we can specify the distance between camera and the character. Well, in this case, it's been specified actually in centimeters. So here in the camera target case, they are centimeters. For example, let's use 500 centimeters, and it would give us another distance between camera and the character. And camera actually will be the camera through which we're looking on the scene and on the character as well. So let's click on play, and as you can see right now we're located a bit more far away from the character than previously. Okay. So as you can see, we can even make the scaling of the character. For example, we can scale it. Let's say in the way it will be two times bigger, and as you can see, our character literally becomes 2 times bigger. Unfortunately, as you can see, it doesn't change proportionally its speed, because the speed component and just speed configuration is not something which is really connectable or connectable to character size, and it's just controlled additionally. Okay. So additionally, we have character movement component, and character movement component allows us to specify how fast will be our character. For example, we can have a default values for walking speed and running speed as well. Okay, so for example, we can change values. Let's say we can double them. In these numerical fields, we can even apply some mathematical equations. So we can multiply values, we can add values, and so on and so on. For example, let's multiply these values twice. Let's save actually everything, and let's launch our game. Okay, and as you can see, our character moves twice faster than previously. So literally that corresponds to its current size. What will happen if we would change its size? Okay, so let's click the capsule component, and let's decrease its size in all directions. Once again, let's save the character, and by the way, after saves, we have to compile our file which we changed. Okay, so let's run the game again. So again, we have a normal size of the character, and let's just move, and as you can see, it moves twice faster than previously. Okay, great. So is the way how we can make these speed modifications. Okay, let's close this game, and let's return to our character. Here on the bottom side, we have my blueprint section. So here we have events, which are being created for the character, and let's take a look on them. Let's try to understand what are those events. Well, we can find out that there are a lot of fancy looking objects, and let's try to understand what are those objects. Okay, so maybe let's take a look on a jump option. So we have event jump, and we literally say that the current character does jumping or stops jumping. Okay, so literally this function jump and stop jump are being implemented in Unreal Engine. So we cannot just modify them. We can just use them. But okay, here it was said that we have an event jump. So when it's been activated. So first of all, we have to understand that this jump event has two cases: when jumping button is pressed and when it's been released. Okay, so let's try to find out where we have this jumping configuration, where we have those event activators. Okay, well, we can find them in settings and in settings, project settings. Okay, in my case, this area is being just hidden here, and definitely here we have to find out a so-called section named input in engine block. Okay, so literally here we have actions. Okay, so we have two types of actions. One type of actions is related to button presses. It's called action mapping, and another type of actions is related to some long press of buttons or a specific button press. For example, we can press W and 1, and each second or each tick our game finds out that W button has been pressed. Move forward event receives value 1. Once it will be figured out that button S is being pressed, then event move forward will receive value -1. And the same can be done for all other key presses. About the action mapping, when we have two cases, released or pressed case, we specify those buttons which are assumed to be just pressed one time and then released. Okay, for example, we can find out that we specified the space bar for that. Okay, so let's say we will create our new action mapping, and we will name it jump 2. So let's say jump 2, and we will say that our character in our character the event jump 2 will be activated when we click, or let's say when we press, let's say key button. By the way, here we have searchers, so we can just type something that will be found out in this possible options list. Okay, in my case, I will use key K. Okay, great. So let's just save everything, and let's go back to the blueprint. And let's click right mouse button on the clean area, and here let's try to find out our event jump 2. So we will type event jump 2. So as you can see, our jump 2 is being placed here, and let's select these two actions being the two character, and let's just say that when a button is being pressed once, we will activate jump operation, and once it's been released, we are activating stop jumping operation. Let's save it, compile, and let's run our project. Okay, so I'm pressing the key K, and as you can see, the character jumps. And sure, I can press this button and just hold it, but nothing really will happen, because actually we have only two states of this event is pressed and released, and that's it. And sure, we can even press a lot of time while it's in a jump action, but nothing really will happen. We will talk about why it happens afterwards. Okay, so that's the way we can create a simplified event. And about the jump, we figured out how it works. Next, now we have the mouse input. Okay, and we have turn and look up. events. Once again, let's take a look in our project settings. What are those events? Okay, so literally we have a turn and lookup. Okay, let's take a look at what do we have. Okay, so we have mouse and X. It means that mouse is being moved in horizontal direction. Here we have the scale. So literally, depending on if we would move the mouse on the right, we will give a value of 1 to the turn event. If it will go in the opposite direction, it will have the minus value. It will be a negative value, but still the same. Okay, the similar for the lookup. So it's just a movement of mouse in vertical direction. And once again, once it's been moved up, the value will be given -1. If it will be going down, then it will be positive value. So it's up to us how we define these values. The main thing is that we will have to use these values which are placed exactly here. Okay, so literally we have a couple of controls related to our character. For example, we can make it going around. So literally we have to specify a value here. So that will be related to the yawing velocity, and we can just connect these pins to say that a value from the axis value will come to the val parameter of the add controller yaw input. The similar happens for add controller pitch input. So once again we have value that comes from here and here, and there could be positive values and negative values, because here it's fine for both directions. I mean about the mouse move, and we can work with it. So we can rotate our camera around. Nextly, what do we have? Well, we have a turn rate and lookup rate. So where those events come from? So we have turn rate. So literally we can press left and right arrows on the keyboard, and the lookup rate activates when we have a gamepad. Okay, I don't have it. So that's why it's impossible to run this event, but at least I can press this left and the right arrows. Okay, let's take a look how it happens. So right, I'm pressing the left arrow, and I'm pressing the right arrow. Okay, so as you can see, our camera is being just moved, and that's it. Okay, and we have the same functions as we have here, so add control yaw input and add control pitch input. Okay, so we have reset VR event. So where we have it. Okay, so we have reset VR. So when we press R, this event will be launched. So, and we will be resetting orientation and position of the camera and character. Okay, let's take a look how it looks like. So right now I move the character and I'm pressing the R button. Okay, nothing really happens, because not always this operation works, because it depends on a specific case. Okay, the next thing, the movement input. So we have two events, so move forward and move right. So move forward will be run once we will press W or S keys, but in case of W, axis value will be equal to 1, and in case of S, axis value will be equal to -1. And we give an input of the movement. So literally we say that that our character will be moved for this value that comes from the event. the event value. And the same for moving right. So we have A and D keys, and they can be pressed for moving our character. And let's take a look at what do we have here. What are those word directions? Which values are being used from other components? So actually, each component here is a value given or value receiving or both function. So here we have get control rotation. So literally we receive a rotation from the self. It means from this exact character, and we use only rotation into z direction. Okay, so we make a so-called rotator. Rotator is just a vector in this case that has two components equal to zeros and z equal to the z from the current character rotation. And literally we have this direction, and we say that okay, we're going to have a forward vector, so the vector in which our character looks, but in forward direction of the character himself. And then we take this value to the word direction. And nextly, for the rotation on the left or on the right, we find out the vector for the right the vector of the rotation to the right from our character, and we take this value to the word direction in which we can rotate our character or move our character, which actually will be the right or left one. Okay, so let's return to our character. So this blue arrow shows the forward rotation. We can even make a duplicate of this arrow, and let's say we will just move it a bit. Okay, so literally, how should we understand all this? So we have the blue arrow that shows the forward direction, and we have red arrow that literally shows the right direction. So we can find out the absolute vector in the world, not the relative, that shows a correct direction of our character in its forward direction or in its right direction. That's the idea. Okay. Okay, we have even input touch. So we have once again input touch, which means we have an event. Let's take a look where this event comes from. So we will try to find it out in a list. So we have, okay, we don't literally have it here. Input touch. Why? Because literally we can add our events even here. For example, if the key, let's say F, will be pressed, so we can use the absolute events, not those which were named, let's say, through the project settings. And for example, when we will press the F button, we can show on the screen some debug text. So debug text can be shown by the function print string, and for example we will have the hello text. In the same time, we can click the color and we can pick the color we would like, as well as we would like to specify for how many seconds this text will be placed on the screen. Okay, and we're going to print the text on the screen and as well print it in the log of the game. And let's run this game, and let's press the F button. And as you can see, once I press this F button, and there's no difference if I still hold this button or I just press it fastly. I have one additional printout hello on the screen. Okay, so literally this is the way in which we can make a very simplified events. Let's say from our character, and since we as the player with number 0 controlling this character, all these events can be run through our actions. If it would be some others players character, then our key F pressing wouldn't help. Then it would be assumed from that player, not from our. Okay, so that's the idea. Literally, our character has a lot of options, as you can see here, and some of them can be even created by ourselves. For example, we have a section variables. So in section variables we can add a variable which will be schematically placed in this list. And for example, we will name this variable as ABC123. And we can select the data type of the variable. For example, it will be Boolean value. Okay, so let's say it will be a Boolean value. We can make this variable editable for each character separately. So we can create a couple of characters and they will be colored differently. For example, depending on this instance. And moreover, if we would like to do this, we would have to click two checkboxes. So instance editable and expose on spawn. So literally expose on spawn means that once we create the character, we'll set up its value, so we'll be able to set up this variable's value. And instance editable means that actually we can edit this value publicly. Okay, so let's run it. Let's save it and compile, and let's take a look if we will have this ABC 1, 2, 3. So here we have the searcher of parameters. So let's find ABC 1, 2, 3, and we can see that we have this ABC 1, 2, 3. Okay, great. So, and as you can see, we can click or we can declick it, and depending on its value, we can do something. Okay, what exactly something? For example, we can set up a material. Okay, so let's create a very simplified material, and let's try to make a different color depending on our parameter, if it's equal to true or it's equal to false. Alright, so what we are going to do? Well, first of all, we are going to go to construction script. Well, construction script will be run once we change parameters of our objects in our game editor, in our scene editor, or it will be just run once when we run the game. So it's something similar to just a construction of the class. But once we change parameters which are being marked as expose on span, then the objects will be recreated, so constructors will be run. Okay, so what we are going to do? So we see that we have the mesh, and mesh has materials. Okay, so let's maybe create our own material. So for this case, we will click the right mouse button here, and we will click on material. Okay, let's double click it, and we will create the base color, and base color will come from the vector, with three values. Okay, so we have it. We can actually double click this constant, and we can select whatever color we like. For example, it will be something pink. Okay, so we will have to save it and apply our configuration. Okay, sometimes apply button is being automatically pressed. Okay, that's great. And then let's say we will try to set up both materials, element 1 material and element 0. Okay, so let's go back to construction script. Let's just double click it, and then let's move our ABC1 to 3 here, and let's take its values. So we will literally we will have to work with all our variables in the following way. So we'll get value or we will set a value. So let's get the value. Okay, so each this object has pins on the left side and on the right side. On the left side, it means that those pins can receive values, and these values can be used within the object. And pins on the right means that we can get values. In our case, we are getting the ABC1 to 3. If we would choose set, then we would have this pin on the left side. It means that our set function waits for the value bind to this pin. Okay, so in our case we are not going to set the value, we are going to use it, but we can use the if statement. So if we would write the if, we would be highlighted on the branch. Okay, so what is the branch? Branch is actually the if condition, and here we connect a value that is being represented as boolean 1, and we connect it to a condition. So literally we have true branch and false branch of our if statement. Okay, so literally we will take the mesh. So once again we can move it here. So we'll work with the mesh object. And we will set material. So we can just write set material. Okay, great. And we will say that the index of material will be 0, and by these yellow arrows we just connect operations, so it's a direction of execution. Okay, so literally we can say that we would like to set up material for the mesh. Material index 0 will be modified, and here we can choose our material we previously created. Okay, and there could be a following case. So we can use let's say new material. So let's copy this name and let's select it here. So we will choose a new material. So new material will be assigned to material index 0, and we will copy the operation, and we will do the same for material index 1. Okay, so literally we are going to copy same operations for case when ABC is not equal to true, so it's equal to false, and we are going to set up maybe initial materials. Okay, how we can find out those initial materials? So we can use a finder. So we are clicking on our object. Oh no, sorry, not here, but in the viewport, and we are going to click on this button, and in our file search we will have this material highlighted. So let's take this name, let's go to the constructor, and let's set up and let's find out this material. And the same will happen for material with index 1. Okay, so we click this button, the searcher, and our material has been highlighted. So we take its name, we are opening the characters construction script, and we find out this name in to assign the material. Okay, that's great. And right now we compiled it, and let's open our game of viewport. Okay, so as you can see, our new material is being assigned, and if we would change the ABC, once again our object is being recreated, and sure, since there is no such value equal to true, then we have the normal materials of our default character. Once again, if we would activate it, well, we would have this material. And in the similar way, we can create a lot of things. But I think this could be the step number 1 in our overlooking of the Unreal Engine. And at this point, I think we can finish at least this material. So try to play with these objects. Try to maybe create additional variables, maybe assign some values. Ensure In the next video we will go a bit deeper in understanding what is the Unreal, how Unreal works, and what things we can create. Okay, so thanks for watching the video, and definitely I will try to make another one in several days. Okay, thanks for watching and see you next time, guys.